Hello everyone, welcome back after a week-long break. Last time, if you remember, in the last class we had revised some of the sums on differentiation. That was our last class, and before that lesson 5 was about implicit differentiation. So we are taking our classes further from implicit differentiation. So this sum here, as you can see, is also a sum based on implicit differentiation. I will solve some of the sums. Today I'll solve some of the sums based on implicit differentiation. So the first one is, if sine y equals to x sine a plus y, prove that dy dx equals to sine square a plus y divided by sine a. So as I can see here, in the proof part, there is a sine square a plus y, isn't it? And I know this square happens if we use quotient rule in the denominator, isn't it everyone? Because if we use quotient rule, then the denominator becomes v square. So what am I going to do here is, just check it out. Sine y equals to divided by sine a plus y equals to x. I will make x as the subject of the formula. Can I do that, everyone? Okay. Or you could have directly differentiated both sides with respect to x. That would also have worked. Okay, but this is the shortest one. Then I can say x equals to just writing the same thing again, sine a plus y. Can I write it, everyone? Okay, now I will do differentiating both sides with respect to y. I will do differentiating both sides with respect to y. Remember, I am not differentiating with respect to x, but with respect to y. So what will this happen, everyone? d dy of x equals to d dy of sine y divided by sine a plus y. Correct? That gives me dx by dy. It's the same thing here. And what is d dy of this thing? I will have to use the quotient rule. What does the quotient rule say? I'll just write it down here. Okay, dx of uv equals to v du dx minus u dv dx divided by v square. Remember this, isn't it? Okay, the second, so sine a plus y into d dy of sine y, the first one, and minus sine y out and d dy of sine a plus y divided by sine a plus y whole square. So I can write the square here. Correct? Okay, now let me rub this part here. Okay, that gives me let me write here dx by dy equals to what is d dy of sine y? d dy of sine y is cos y, isn't it, everyone? Okay, so it will be sine a plus y, and d dy of sine y is cos y. Correct? Minus, because I am differentiating with respect to y, so no chain rule. Okay, then what is d dy of sine a plus y? Check this out, this one. This will be sine y and cos a plus y. That's correct, but I think it will be followed by d dy of, okay, d dy of a plus y, isn't it, everyone? A plus y. Okay, let me rub and rewrite this. It'll be cos a plus y and d dy of a plus y, but d dy of a plus y would be constant is 0 and 1, so that will vanish in the next step, divided by sine square a plus y. Correct? Let's check. Yes. Okay, finally dx by dy equals to, now this looks like sine, okay, a plus y. Let me rewrite again, cos y minus, okay, let me zoom in a little, sine y cos a plus y, and this becomes 1, so divided by sine square a plus y. Correct? Okay, finally, doesn't this look like a formula, everyone? Check out the numerator. It looks like sine a cos b minus cos a sine b, isn't it? So there's a formula for that. What is the formula for sine a cos b minus cos a sine b? That's sine a minus b, and this acts as a, y acts as b, so a minus b divided by sine square a plus y. Let me explain again, how does it work. Okay, let me show in red color. Sine a cos b minus cos A sine B. So this is like a and this is like a B, isn't it? So that becomes sine A minus B. Correct now? So this 2 gets cancelled. So finally I have, let me write it down here, dx by dy equals to sine A divided by sine square A plus y. So if you flip it using invertendo, if you remember, so it will become dy dx equals to sine square A plus y divided by sine A. So this is an interesting sum. I have solved it the opposite way and just inverted it in the end because I created dx by dy and then just flipped it to get dy by dx in the end. So this method would also be correct. Also, if you want to directly do it by differentiating both sides with respect to x also, it's absolutely correct. Okay, another sum that I would like to solve from implicit function is the one that you see here. If x to the power y dot y to the power x equals to a to the power b, find dy by dx. Remember, this is x to the power y dot y to the power x, not plus. I suppose we have already solved these type of sum, isn't it? Not like this. So this is different from this one. So what will I do? Had it been like this, then I cannot use log. But since it is multiplication, I think I can use log both sides and simplify. So let me write it down here, taking log both sides. So both sides. So what do I get? Log of x to the power y, y to the power x equals to log of a to the power of b. Correct? Now I can simplify this. Log, this is dot, so it becomes plus x to the power y plus log y to the power of x. Product rule, and this becomes b log a. Similarly, the power rule is being used here. Similarly, I can use the power rule here as well. Y log x plus x log y equals to b log a. Correct, everyone? Now time to differentiate. So differentiating both sides with respect to x. Now I can differentiate because it's quite simple, correct? D dx of y log x plus x log y equals to d dx of b log a. Can I do that? Okay, so let me put it in bracket. Now let's simplify this. I think I'll have to apply product rule here. So what would be the product rule, everyone? Log x into d dx of y plus y into d dx of log x. That's the first one, isn't it? Okay, let me put it in bracket. Plus log y into d dx of x plus x into d dx of log y. That's the second one, correct? Okay, and d dx of a constant, this is constant, as you know, isn't it? B as well as log a is constant, that's 0. No need to write anything, correct? Okay, that gives me log x dy by dx plus y by x, because d dx of log x is 1 by x, plus log y simply, and here I have x by y into dy by dx, because d dx of log y follows chain rule. First I'll have to do 1 by y followed by dy by dx equals to 0. Let's bring all dy by dx together. So these two moves to my right, so that gives me dy dx common from these two, if you see here, and I'm left with log x plus x by y, and that side y by x minus log y, correct? Because both moves to the other side. Finally, dy dx equals to minus common y by x minus log y, that should be plus, divided by log x plus x by y. You may say this is the answer, but let's try to simplify a little. There is no harm in simplifying. So what I do, I'll take x common, LCM in the numerator, so I'll get y plus x log y divided by, minus is still there, divided by y LCM, y log x plus x, correct? So finally that gives me dy by dx equals to this moves here and this goes to the extreme above, so y minus y plus x log y whole divided by x y log x plus of x. So that's the final answer. That's dy by dx for this particular sum. Here I have another sum, that's the third one here. You might have done this sum earlier. I had given this sum as homework in some previous exercises, but I see some of you have problem with this sum. I see many of you couldn't solve this sum, so I'm redoing this sum, though it was a part of your homework. So how would you start with this? So I have x to the power y equals to e to the power x minus y. I need to prove dy dx equals to a log x divided by log x plus 1 whole square. So since you see there are powers, variables in the power as well, so I can use log, taking log both sides, taking logarithms both sides. So what do I get? Log x to the power y equals to log e to the power x minus y. You could have directly used the formula as well, dy by dx. What is the direct formula of x to the power y? X to the power y ddx of y log x, like that. Okay, so y comes out, log x, and here x minus y, and log e. Everyone knows what is log e. You know, in calculus the base is e, so log e is 1. Please remember this. So I have y log x equals to x minus y. Correct, everyone? Check this out. So now what can I do here? So I have check this out. Can I bring the y this side? So y log x plus y equals to x. Can I do it like this? It will be absolutely correct. Then y common, log x plus 1 equals to x. Is that correct? Then finally, can I make y as the subject? It will be x divided by log x plus 1. So that's the best trick you can apply here, because that will make the sum very, very simple. Now if you see here, there is a log x plus 1 whole square, which happens if there is a quotient rule in the denominator, isn't it, everyone? For the quotient rule in the denominator, when you use quotient rule, the denominator function becomes squared. So check the denominator function, log x plus 1. So now I can differentiate ddx of y equals to ddx of x divided by log x plus 1. Let's try it out. What do I get? Now that gives me, let me do it just here, dy by dx on my left, and second, that's log x plus 1 into ddx of x, the first, minus first ddx of log x plus 1 divided by log x plus 1 whole square, isn't it? So that gives me dy by dx equals to, what is a ddx of x1? So no need to write that, log x plus 1 minus x, and what is ddx of log x? 1 by x and a 0, no need to write. So that gives me log x plus 1 whole square, and finally dy by dx equals to log x plus 1 minus 1 divided by log x plus 1 whole square. So 1 and 1 gets cancelled. So what's the answer? Dy by dx equals to log x divided by log x plus 1 whole square. As simple as it can be. Okay, so that is how we solve this sum. Though you can simplify this. Actually the proof, this was actually like this, log x divided by log x log x e whole square was dy by dx. Actually the question was this, but I thought some of maybe it would be too difficult for you. That's why I had simplified and given my own version of this question. Actually the question says prove that dy dx equals to log x e whole square. I had given you the simplified version. How to make it log x e whole square? Let's try to figure out this one. This one would be quite simple. What is 1? 1 means log x. So dy dx, log e. So log x divided by log x plus log e whole square, and that can be simplified as log x, and the product rule, because plus would mean product, isn't it? So that becomes log x e whole square. For those who haven't understood this one, this formula, log a plus log b in logarithm means log ab. So that's why I have multiplied xe. So I can also do this much. So though this is your answer, because I had just given you to prove this much. So is that correct, everyone? So that's how simply you can prove this differentiation sum. So please remember, if you simplify it properly, and the sum becomes very, very simple.